Alrighty guys, Exemplar Scholars, instead of doing a Monday morning assignment or watching another YouTube video from somebody else, I'm going to try to teach you guys very quick, the quickest way. I had to just delete the last one, it wasn't as good as I wanted it. So I'm trying the quickest way to introduce a complicated subject, which is quantum numbers. So we're going to go through it quickly. Guys, you're going to be confused at first, then it's going to make more sense, which is bear with me. If you ever have questions, come in and see me before or after school. I think I'll open up questions at the beginning of class for answer a question or two about quantum numbers. So basically, I'm not going to show you this video on this one. Electron cloud, we talked about it, right? It's basically, we don't know exactly where those electrons are going to be at. They're moving around constantly, but through experimentation, they can have a rough estimate of where they're likely to be, the probability of where they're likely to be in those electron clouds. So this is what quantum numbers are basically doing here, quantum mechanics. So orbitals and quantum numbers. So a quantum number specifies the property in orbitals and the property of electrons. Basically, all this is saying is that it's telling you where the electrons are going to likely be, and it changes depending on element to element. The principal quantum number is symbolized by N. So this may be something I want you to know. So the principal quantum number. It's the main thing you take with this is the main energy level. Okay. That's symbolized by the lowercase n. All right. So it is the main energy level of the electron. This is going to be confusing at first. It'll make more sense. The angular momentum. So I'm just writing it to the side. You probably can't see it. This is for me to come back to later. Okay. Angular momentum. This tells you the basic shape of the electron cloud, basically. All right. It tells you the shape of the orbital. All right. Like angular momentum. So if you want to think of one word to symbolize with this, so this word, one word, main energy. One word, shape. Shape of the cloud. So if the orbital confuses you, shape of the cloud. The clouds have different shapes. So just kind of keep that in mind. Now you have the magnetic quantum number. This is one of the hardest ones for students to understand. Magnetic quantum number. The orientation around the nucleus. So that is symbolized by M. And I'll explain that one. That one's hard for me to say in one word. It's kind of like, is it around the x-axis, the y-axis, or the z-axis? So you can think about a three-dimensional plane. You have x, y, and z. Okay, so this is going to be x, this is going to be y, this is going to be z. How is the orbit, the clouds? The clouds on the x-axis, on the y-axis, or on the z-axis? It's orientation. Okay? So I think of a magnetic pole, poles, that's kind of how I remember its orientation, either here, here, or here. Alright? That's kind of a tricky one for students to know. Now spin is probably the easiest one. Okay? So the spin quantum number. The spin, it just has two values. It's a half or minus a half. Now don't worry as to why they got that. All I want you to know is half or minus. It's a fundamental spin state. Basically it's either spinning this way or it's spinning the opposite way. So typically if you have two electrons in an orbital, one's going to be spinning one way, one's going to be spinning the other way, so they can stay as far away from each other as possible. Because remember, they have the same charge. So they're going to stay as far away from each other as possible because they're negatively charged. Okay, and they're traveling very, very quickly. And one thing I want you to know about an orbital, which is maybe noteworthy, you can only have two electrons in each orbital. And if orbital is confusing you, just think of it as different shapes of clouds. Those are different electron clouds where they're going to be. Alright? So, two electrons in each orbital. Alright? So this is kind of confusing. So we have these four quantum numbers. We have the principal energy. We have the angular momentum, which is the shape of the cloud. The magnetic quantum number, that is like how it's oriented around the nucleus, around the x, y, and z axis. The spin, is it going clockwise or counterclockwise? I'm going to show you this because I think it's important. It kind of summarizes this well. So I'll show you this real quick. Hopefully it works. Yes. Yes.
The principal quantum number n is a positive integer describing the energy level of the electron. For example, an electron for which n equals 1 occupies the first or lowest main energy level and is located closest to the nucleus. The angular momentum quantum number L can be any integer from 0 to n minus 1 and describes the shape of the orbital. The s orbital can be represented by a sphere. The p orbital can be represented by a dumbbell shape. The d orbital is primarily shaped like cross dumbbells, but can also have a fifth dumbbell ring shape. The magnetic quantum number m can be any integer from -1 to +1 and describes the orientation of the orbital. Orbitals run along the x-axis, the y-axis, and the z-axis, as shown in this p orbital. The spin quantum number has only two possible values, +1/2 and -1/2, which indicate the two fundamental spin states of an electron in an orbital. A single orbital can hold a maximum of 2 electrons, which must have opposite spins.
So that was, hopefully it makes a little more sense now. So we're talking about those quantum numbers. Hopefully you saw the spider kind of just right in the middle of that screen. That was interesting. So what I'm showing you guys is that, remember, in each one of these I can only fit how many electrons? You should have said 2. So 2 electrons here, one going one way, one going the other way. That is the spin quantum number. So these are all of the, this is basically saying the shape of these. This is that's the angular momentum. So these are the different cloud shapes. Now what's confusing is that, remember, we're talking about a three-dimensional object. It can be on the x-axis, it can be on the y-axis, or it can be on the z-axis. Okay? So those dumbbells can be shifted from this axis to this axis to the z-axis. So here on the P we could have a total of 2 in here, 2 in here, or 2 in here. But these could all be on top of each other. Okay? So you can have an element that can have all these orbitals filled. Okay? So this could have, so the P's could have a total of 2, 4, 6. The D's, don't worry about it. We're not going to spend a lot of time with this. They didn't show F's because it gets really complicated when we start talking about these things. But one thing I want you to know that's kind of important is that when I talk about valence electrons, we're talking about ones that are on the outside. We're talking about our S and P orbitals, or S and P clouds. Okay? S and P orbitals or S and P clouds. That's what we're talking about. D's, we're not going to worry about it. It does something weird there. So we're talking about these things here. So the valence electrons are the S and the P's. Remember, the shape of this is a sphere. I remember the S stands for the sphere. This is a dumbbell. Okay? That's a dumbbell. And the D is a double dumbbell, but I don't want you guys don't have to know that. Okay? So the D is a double dumbbell, this is a dumbbell, that's a sphere. And what does this mean? These are the shapes of clouds. Now why is it that with this, we only have one orientation? Well, if you move it around the different axes, it doesn't matter. It's a sphere, right? It's going to be the same circumference around, so it doesn't even matter what orientation it's around. It doesn't matter on the axes. Here it does, because it can be on up and down, here, all the different axes. So that's kind of an important distinguishment, in fact, between the two. Okay? You don't have to know this. Don't worry about this. Well, all I'm going to show you now, let's bring all this together. Now, I'm going through this super fast. So, let me show you a periodic table, and I think it'll make a little bit more sense. We'll practice some of this. Alright, so here we're going to go to another PowerPoint. I'm going to end the slideshow real quick. Bear with me. And then I'm going to bring this one up, because it has a periodic table here. Now, notice, we're talking about helium. Helium. So, we're going to talk about this element right here. So, hopefully you're looking at your periodic table, you have that out while you're doing this. So, I'm looking at helium. So, helium has 2 protons, 2 neutrons, and 2 electrons. Okay? So, if I was going to look at this again, I have, now this is also critical. When I talk about my principal quantum number, I'm talking about N. So these are the different energy levels right here. The main energy levels. Okay? Those are all the different energy levels. 1, 2, that's how you can find these quantum numbers. The first quantum number here, that is N. That is like right there. So if I was going to write that for helium, I would write that down. So they're on the first period here. Okay? So we would write 1s. Okay? Because I have the s, I can fit how many electrons? I can fit 2, correct? So if I want to say 1s2, this is telling you the number of electrons. Alright? Another way of writing that is like this. 1s here, 1, 2. So what this is saying is this is the spin quantum number. This is the spin. Alright? It can either be clockwise or counterclockwise. This doesn't really have a choice because it's only around the x, y, or z axis, right? So this is the m quantum number. That tells you its orientation. That little line here tells you it's the m quantum number. It only has one way it can do it. This is the angular momentum, or the shape, okay? That is the shape of it. So it is a sphere. This is the principal quantum number. So by looking at this, I have 1s2, so that's the number of electrons. I'm on the first period. I'm on the s here, because I can only fit 2 in there. Alright? So this is a way you can talk about these. Let's do another one. Let's do another one real quick. Alright? Let's do another one of these. Now, let's say I'm going to do I want to do lithium. Okay? So remember, what we're saying with this is we have to fill up, lithium has 3, there's atomic number of 3. So if it's balanced, I know it has 3 protons, 3 neutrons, and 3 electrons. Okay? So I got to fill that up. But there's I think it's the Aufbau principle, you don't have to know that. You have to start from the bottom and work your way to the top. It's like climbing a ladder. You can't just jump up to the top. You have to start from the bottom and work your way to the top. So, if I was going to do this, so we're talking about lithium. Lithium, and it has 3 protons, 3 neutrons, and 3 electrons. So, I want to go here, just like you're reading from left to right. So, I want to do 1s2, alright? So I just did this. I just get 1s1, 1s2, alright? And then this was going to be, so now lithium is going to be 2s1. What? Check it out. So this 1 valence electron right here, correct? So I have 1s2, and I have 2, because I'm on period 2, s1. Guess what this adds up to? These are a number of electrons, right? Boom, boom. These are going to add up to 3. Well, guess what I have here? I have 3. Now, if I want to do this the other way, okay, the lines and arrows, I have 1s, 1, 2. Okay, these are the number of electrons, and I have 2s. How many electrons do I have? I only have 1. So that's talking about that. These two are talking about that. Okay? So remember, this is my spin, so this is just going to have 1 electron in it, right? This is going to have 2 electrons in it. Making more sense, remember, this would be the energy level, the N, principal quantum number. This is just saying, remember, these are both spheres though, right? These are both spheres. Now, let's do another one. Let's do another one. So now we're going to do another one, and hopefully it'll start to sink in and make a little bit more sense. Let's do neon. It's a noble gas. So we're going to do neon. So neon has, let's look at it again, has 10 protons, 10 neutrons, 10 protons, 10 neutrons, 10 electrons. Okay? 10 protons, 10 neutrons, 10 electrons. Remember, we have to do Aufbau principle. We have to start and then work our way up here. Okay? So now, I have to start here. So this is 1s. So I have, so I can do this right, so I get in the way, 1s2, because I'm reading here 1s1, 1s2. So then we have 2s2, okay, because remember, you can only fit 2 in each one. You can only fit 2 in each one of these orbitals. Now, where it gets a little bit confusing. So we have 2s2. Now we're going to have 2p. Now, if you remember, p had a bunch of different ways it could be flipped. Remember the x-axis, the y-axis, and the z-axis. This is where it gets kind of tricky. So it can fit up to 6, okay? So it can fit up to 6. So we have 1, 2, 3, 4, 5, 6. So it can fit 6 electrons in there. Like, what are you talking about? So this would be the electron configuration for neon. 1s2, 2s2, 2p6. Now, before you get too confused, let's flip this. Let's do it the other way. 1s. Oops, I gotta have them go in the opposite direction. That violates the principle. 2s. And we have 2p. Now, remember I said those could go up the different axes, right? Remember, like I said, we have this, we have this, we have this. We have our x, we have our y, and we have our z. It can be around this axis. That would be this one. Okay? It could be around the y-axis. That would be this one. Or it could be around the z-axis. That would be this one. Remember, it can be like boom, boom, boom. How many can fit in each one of those? Should have said 2. 2 can fit in each one of those. So we have 1, 2, 3, 4, 5, 6. Okay? So that would be the electron configuration for neon. Okay? Now, these are going to be our valence electrons right here. Those are going to be our valence electrons. They're the highest energy level. They're going to be on the outside, the highest rung of the ladder. Alright? This is not going to be a valence electron. We don't care about it. It's not important for what we're doing. Alright? So, let us do one more. Let's do another one. Okay? And I'm going to show you something that's kind of, I'll do 2 more, and hopefully this will start making sense. So, let's go back to here. Let's do boron. So we're going to do boron. Boron is 5, so we have 5 protons, 5 neutrons, 5 electrons. Okay? So we have to start from left to right. We have to fill up from the bottom. So we have 1s2. Okay? Because that's going to be our first energy level. So we have 1s2. Then we're going to have 2s2. Okay? Because then we have 2s2. Then we're going to have 2p. We have 2p. We're going to 5. Boron, right? That's what we're doing. Boron. So this is going to be 2p1. Maybe what I think is that? So this will make more sense. So now we have 2s2. Boom. 1s2. 2s2. 2p1. We're on the second energy level right here. 2p1. So now that's boron. So if I want to draw this out the other way, I have 1s, 2s2, 2p, 1, 2, 3, because there's 3 different ways, right? Just have 1 there. These are going to be filled. These are going to be filled. Okay? And that is that diagram there. Okay? Now, another thing that will help you out is that these guys, right, you may write this on your periodic table, these are called, excluding this guy. This is the P block. Okay? This here is the S block. Alright? All of these react the same because they have the same number of valence electrons. These are the S blocks, these are the P blocks, and these are the D blocks. We don't really worry about this. The transition metals and this guy here, we're not really worried too much about the D blocks. Yeah, these are the D blocks, okay? So, each one of these have the same valence electrons. All of these have the same number of valence electrons. These are all the P blocks. These have so remember what I said the valence electrons are with the S's and the P's. Alright? This will make more sense as we go through another example. Alright, so now, if I had to do all of these, okay, this would be 1s1, 1s2. Okay, this would be, all these would end in s1. All these would end in s2. All these would end in p1. All these would end in p2, p3, p4, p5, and then p6. Okay? Now, this is going to be a little bit confusing for you guys, and that's okay. I'm going to open up questions for that. You can ask questions every day during class. I'll allow like 1 or 2 questions that you guys come up with as a class. All right. I'm also going to do a couple exercises where it makes more sense when you see this. Okay. So hopefully this is a good introduction to quantum numbers. It's a very, very quick explanation of these things. All right. So hopefully that helps.